Have you ever really stopped to think about how a simple lump of metal becomes a car engine? Or, how a tree turns into the very chair you might be sitting on? Well, today we're diving into that incredible world of manufacturing. The whole journey from raw material to finished product. A story shaped by fire, by force, and by a whole lot of skill. So we're going to step right into the foundry and the wood shop to uncover processes that are, believe it or not, both ancient and absolutely essential to our modern world. Think of this as the creator's journey, taking something basic and transforming it into something real. Okay, so it all starts right here, with these raw, unformed billets of copper. I mean, they don't look like much right now, do they? But they hold all the potential to become something way more complex. Our big question starts with this raw potential. And it ends here, with these precisely shaped, totally functional parts. So how in the world do we get from A to B? Well, it's not magic. It's this brilliant fusion of hardcore engineering and real, hands-on craftsmanship. No, really, think about it for a second. From the desk you're at to the engine in your car, pretty much every single object has a story of how it was made. Today, we're going to pull back the curtain on a couple of those stories. Let's start our journey in the intense heat of a foundry. We're going to explore one of the oldest and, honestly, one of the most powerful methods for shaping metal: casting. So what is casting exactly? Well, the concept is actually super simple. I bet you've already done it. Think about making ice cubes or maybe a Jell-O mold. You pour a liquid into a container, you let it set, and boom, it takes the shape of that container. Casting is the exact same idea, just, with superheated molten metal. This whole complex-looking industrial process can really be broken down into 4 essential steps. It's pretty straightforward. First, you melt the metal. Then, you pour it into a pre-shaped mold. After that, you let it cool down and get hard, and then you just pop the finished part out of the mold. That's it. Now, the most common way to do this, and for good reason, is something called sand casting. It's incredibly versatile and pretty cost-effective, especially for making really complex shapes. You can see it here. The molten metal is poured into a mold that's made of tightly packed sand. It just flows into a cavity that was created by a replica of the part, which has a cool name: a pattern. Okay, let's break down some of that jargon, because it's not as complicated as it sounds. The pattern, like we said, is just the replica of the part you want to make. The mold box itself, called a flask, is basically like a clamshell. The top half is the cope, and the bottom half is the drag. And hey, what if you want to create a hollow part? Simple. You just place a solid piece of sand, called a core, right inside the mold before you pour the metal. And this isn't just for making small trinkets. Oh no, we are talking about heavy-duty, absolutely essential parts of our world. Huge engine blocks, massive machine tool beds, and even the iron pipes that bring water to our homes. They're all made using casting. All right, now let's leave the intense heat of the foundry and head over to the quiet precision of the woodshop. In here, strength isn't forged in fire, it's created through incredibly careful cutting and joining. In woodworking, it's all about the joint. A tenon joint is kind of the workhorse, a simple rectangular peg in a hole, great for basic frames. But the dovetail joint? Now that's the artist. Its interlocking pins create this powerful mechanical connection that literally fights against being pulled apart. It's the hallmark of high-quality furniture, not just for its strength, but for the incredible skill it represents. Another really clever technique is the half-lap joint. You basically carve away half the thickness from 2 pieces where they cross, so they can join together to be perfectly flat and flush. It's such an elegant solution, and people love it for its clean look. You get a strong connection with no visible nails or screws. You'll see this in everything from sturdy window frames to classic picture frames. But here's the thing. Whether you're working with metal or wood, no material is ever perfect. A true craftsperson, a true creator, understands how to work with, and sometimes how to overcome the natural imperfections of whatever they're using. When it comes to wood, defects usually fall into 2 main buckets. You've got natural defects, which are basically part of the tree's life story, marks left over from how it grew. Then you have artificial defects. And yeah, those are the ones we introduce, usually when we're processing it, like stacking or drying it the wrong way. So here are 2 classic natural defects you've definitely seen before. Knots are those dense, dark circles left behind where a branch grew out from the trunk. Sometimes they look cool, but they can definitely weaken the board. And shakes are splits or cracks that run along the grain, usually caused by stresses on the tree while it was growing. And then you have the artificial defects. Warping is what causes a board to twist, while cupping creates that curve across its width. Both of these are almost always caused by uneven or improper drying. And this highlights a really crucial point. How you handle the material after it's cut is just as important as the material itself. So, we've seen the fire of the foundry and the precision of the woodshop. We've looked at the challenges, the techniques. Now, let's bring it all together. So, what have we learned here? Well, at its heart, manufacturing is all about transformation. Whether you're using intense heat to shape molten metal or precise cuts to join pieces of wood, the goal is always the same: to create something strong, useful, and lasting. And getting to that goal, always means understanding and adapting to the material's built-in imperfections. And that really brings us to a key insight. It's not just about making something, it's about choosing the right way to make it. As one source puts it perfectly, the goal is always to find that sweet spot, that perfect balance between the process you use, how much it costs, and the quality you're aiming for. And all of this leaves us with a final big question to think about. I mean, we live in this incredible age of automation and mind-blowing techniques like 3D printing. So where do these ancient foundational crafts of casting and woodworking fit in? What role are they going to play in the future of how we make things?